So today is really pretty easy as far as new material goes. There's going to be a lot of factoring, which we'll do. And then tomorrow we'll be doing adding and subtracting rational expressions, which is a little bit more complicated, but still not too bad. So today we're going to do a real quick little 4-problem Kahoot. If you took notes or watched Matthew's lecture, it should be super easy. And then we're going to do most of the factoring that is required for today's lesson. And then we'll finish out bookwork 7.1. So let's go. Oh, test 7 is Wednesday the 25th during class time. The review is already up. If you want to take a look at it. If you want to, because that Wednesday is the day before Thanksgiving. So if you want to, you could take it earlier on Tuesday, November 24th, right after class. Just let me know what your preference is. Try to let me know by Monday so I'll know how to prepare the tests for everybody. Okay, so let's do this again. Extra credit for those people that participate. For some reason you can't log on, just please follow along because it will be helpful to you. This one came right off the notes, so you have your notes in front of you. It should be super easy. Okay, good. So the main thing when you're doing this is that you can only cancel factors, things that are being multiplied together. So anytime there's a plus sign or a minus sign, that ties that term together with the other term. So if it's separated by addition and subtraction, you can't cancel. The only thing you can cancel are factors that are the same. So in this numerator, you'd have to factor the x out, and you'd have x times x plus 5. And the denominator would turn out to be x plus 5 times x minus 1. And the x plus 5s would cancel, and you'd be left with x over x minus 1. So just make sure that you know that you have to factor. Those are little arrows, because I don't really like to use equal signs, because then people start getting confused between, I feel like, expressions and equations. But okay, yeah, this is correct. On this one, I just factored out the 6 in the numerator of the second fraction. And when you factor out a 3 here, you get 3 times x squared minus 1, which is the difference of two perfect squares. So that turns out to be 3x minus 1 times x plus 1. And then x squared minus 16 is the difference of two perfect squares. It factors to be x minus 4 times x plus 4. And then it's just a matter of canceling common factors once you combine the two terms using multiplication. Okay, good. Most of y'all got it good. And really, from the very first step, it's wrong, because you're dividing. This is like 4x squared minus 32x over 1. And when you divide, you keep the first fraction just like it is, but you reciprocate the denominator fraction. So this should have been, instead of 4x squared minus 32x over 1, it should have been 1 over 4x squared minus 32x. And then I made a bunch of mistakes down here too, but that was, you could have just stopped right there. Last one. What's the domain of this function?
Definitely didn't go into depth with the notation where it's x's and the real numbers.
I wasn't sure how you showed it, so I wanted to make sure it was,
I put everything else. I put the x and the slash x.
Yeah, I'm not picky about that. I just didn't know how much you were, so I
didn't specify the real numbers, but I put everything else. If they just put the inequality in there, that's like good enough for me.
Me too.
Or if they do it in interval notation, I was also showing that. It's a little weird.
Yeah, if you just wanted to put x not equal to something and x not equal to something, and you didn't want to mess with all the rest of that notation, that's fine with me. Or if you wanted to use interval notation, that's fine too.
But yeah, that's set builder notation.
Okay. So let's look at this one real quick. Okay, so whenever we're asking for the domain, we're asking for, really what we're asking is what can x not be? And so all you're really concerned about when we're working with rational expressions usually is what's in the denominator. Whatever's in the denominator can't be equal to 0. So this guy and this guy cannot be equal to 0. So x can't equal to 0, and also x cannot equal to -2. If you cancel the x plus 2's, that's fine. That's how you would simplify this, but the domain still does not include that -2. So you always want to give the domain before you start simplifying the function. Okay. So now, good job, you guys. Okay. So now let's look at, and I did put this up on Blackboard. If you want it, you don't have to get it, but if you want it, you can. All right, so what we're going to do to start out with is do all the factoring that is going to be involved in solving these problems. And then once we've done that, we'll go back and actually solve the problems. So remember that when we're factoring, the first thing you always want to do is look for GCF. Then if it's a binomial, ask yourself, is it the difference of perfect squares? And if it is, go ahead and factor it that way. And if it's not, you're through. If it's a trinomial, after you've factored out the GCF, ask yourself if you can factor the rest of it by using the AC or the box method. And if you can, then do it. And if you can't, then you're through after you factor out the GCF. And finally, if it's 4 terms, after you factor out the GCF, ask yourself if you can factor by grouping. And if you can, you do it. And if you can't, then just leave it alone. So the first ones I want to start out with are the binomials. And these I've listed in the order that they appear in your homework. but we're going to go through and do the binomials and then the trinomials and then the 4-term polynomials. So how would you factor a squared minus 4?
You can square root all of it.
Yep. So how do you factor it then? How does it factor?
I mean, so I put a parentheses, and well, no, not a parentheses. I do like a square root. And then inside of it, a squared minus 4. And then I'd solve it as best I could, which would be a
Nope.
minus
It's
4
okay. Wait, Michael, it's not an
or
equation.
IA.
Nope.
Oh, it's not an
Because,
equation. Okay.
It's just yeah, it's just an expression. So you're not going to be solving it because there's no equal sign, right? It's just what would you classify this as? It's a binomial, and what's special about that binomial?
It's a perfect square.
Yes, it's the difference of two perfect squares.
Yes, difference of two.
So how would that factor? That's all we're doing right now is just factoring.
When it's a difference of two perfect squares, you can split it into 2.
Mm-hmm.
And one of them would be plus and one of them would be minus.
Okay, so you would write.
Oh, okay. Sorry about that. So a minus 2, a plus 2.
Yes, that's what I'm looking for. Exactly. So if it's a binomial, first thing you say, is there GCF? Nope, not GCF. Is it a difference of perfect squares? Yep, it is a difference of perfect squares. So I factored it that way. All right, so let's look at the next binomial. What's the first thing we want to do? On number 3? What's the first thing we always do?
GCF.
GCF, right. What is the GCF?
8b.
8b. And that's going to leave me with what? What's left?
B minus 4.
B minus 4. Can we take it any further than that?
No.
No, that's as far as we can go. Because this new binomial in here is not the difference of two perfect squares. So once we've factored out the GCF, we're through. Okay. All right, let's look at the next one. What about number 5? P squared minus 16. How would that factor?
I think you missed one up there, number 4.
Oh, I'm just doing the binomials.
Oh, okay, never mind.
Yeah. How would you factor P squared minus 16?
Same thing. Difference of perfect squares.
Difference of perfect squares, right. What about number 7? What's the first thing we would do on 7?
Factor out 2y.
Mm-hmm. Can we go any further than that?
I don't think so.
Nope. Right. The only time you can go further is if what's inside of the parentheses is a difference of perfect squares. Otherwise, you just stop. Okay. How about number 12?
You got the GCF of 5.
GCF is 5, right? That's it. So there's just a GCF, and what you're left with is not a perfect square, difference of two perfect squares, then you're through. And then number 16. Timothy, Aurora, someone that hasn't spoken yet?
X plus 5 and x minus 5.
Yes, ma'am. And then what about number 17?
GCF is going to be 6.
GCF. And then you're through. And what about number 19?
So are you asking me about 19?
What's that?
Were you asking me 19 or?
19,
Okay. So it's going to be x plus 81 and x minus 81. Sorry, parentheses.
X plus and X minus.
9, sorry.
What goes, what's the square root of 81?
9?
Mhm.
Sorry, is my microphone working?
Yeah, I can hear you.
Okay, just checking because said it a few times.
Yeah. So that's right, Timothy. So you make sure you take the square root of the perfect square. All right. So while I've still got you, Timothy, can you do number 20?
Sure. All right, GCF is going to be 3 and 3x.
3x,
Okay. And then x, sorry, parentheses, x minus 9.
Yeah. So that's it. So anytime you hit a binomial in a problem, just say GCF first, and then if there is no GCF, if it's the difference of squares, then you factor it that way. And if you factor out a GCF and you're not left with a difference of squares inside the parentheses, then you're through. Okay, so then let's look at the trinomials. So remember that if there is not a leading coefficient, or I'm sorry, if the leading coefficient is 1, then all you have to do is come up with two numbers that multiply together to give you the negative 16 and add together to give you the 6. So what are those two numbers? So just start thinking of
Which one are we
factors.
on?
We're on number 2.
Oh,
We're back. We're going back, and I'm just doing trinomials now.
-2 and 8.
Yes, -2 and 8. So this just factors to be. So if it's going to factor, it's always going to be a parentheses times a parentheses, right? And so when you figure out the two numbers that multiply together to give you negative 16 and add to 6, which was 8 and -2, because 8 times -2 is negative 16, and 8 plus -2 is 6, you just write those numbers, plus 8 minus 2, and that's it. So first thing, always, no matter what kind of polynomial you have, GCF. Then if it's a binomial, you're just looking for difference of squares. That's the only thing that can happen after you factored out the GCF. If it's a trinomial, after you factored out the GCF, the only thing that's possible for you to be able to do is factor it by whatever method that you like to factor. All right, so on number 4, it's the first thing we do on this trinomial.
GCF.
GCF. And people forget that all the time. I'm guilty of it as well. And you make your life so much more difficult if you forget the GCF. So the GCF is 2. And so I'm going to factor that out, and I'm left with b squared minus 3b minus 40. Now I have a trinomial that has a leading coefficient of 1. So I'm looking for two numbers that are going to multiply together to give me negative 40, and at the same time add together to give me negative 3, if there is such a thing.
-8 and 5.
So it's going to be -8 and +5, right? Because -8 times 5 is -40, and negative 8 plus 5 is negative 3. So all you have to do here is write your two little sets of parentheses. It kind of looks like a buttocks. And every time I write that, I'm like, oh, that kind of looks like butt cheeks. So this is going to be x minus 8, x plus 5, and don't forget the 2. Okay, and number 6, how is that going to factor? We want two numbers that multiply to negative 36 while at the same time adding back to negative 5.
$36 being a perfect square wouldn't affect this. I thought that there was some kind of perfect square rule or something. Or
It
is it
could
just if
be
a
a perfect
coefficient
square
is-
trinomial, but this one is not. Yeah, you could look at it. If it was going to be a perfect square trinomial, well, there's no way it could be because of the signs also. So
Oh,
it's not. Yeah, it's a good thing to look for that, but in this case, it's not going to be one.
Is
Yeah,
it negative
four.
9?
uh,
Oh,
Uh,
Oh, good, Elliot.
negative 9.
negative 9 and 4.
Negative 9 and 4, good. Negative 9 times 4 is negative 36. Negative 9 plus 4 is negative 5. Got our little parentheses. We'll have a P, and then a minus 9 and a plus 4. So if you've got a trinomial that does not have a leading coefficient, that's not if it's got 1 as its leading coefficient, then these things are pretty easy to factor. Okay, so now, Michael, you were talking about a perfect square trinomial, and number 8 is a perfect square trinomial. So if you recognize that, you can factor
So-
it that way.
but that's because it's why? Because it's positive?
Well, it's
Oh.
because if this number is like, this is a 5 squared, right?
Right.
And this is a 2 times 5. If that's the case, then it will be a perfect square trinomial.
Oh,
If this,
Okay.
just as long as these numbers are the same.
I thought it had to do with the first and the last number, not the middle one.
Oh, it does.
I guess
It
I was
has to
off.
do, the first and the last have to be perfect squares.
Ah,
But then
okay,
the middle term is the check, kind of.
okay.
See, like here, up here, the first and the last were perfect squares, right? But for one thing, there's nothing that will square to give you negative 36, right? So,
Ah, I see, yeah.
so that won't ever, if you've got a negative constant on the end, it's not ever going to be a perfect square trinomial.
Yeah, I was gonna
So
say you
this
get
one, if you noticed that it was a perfect square trinomial, it would factor to be x plus 5 times x plus 5. Okay, if the trinomial fit this classification. If you didn't, and half the time I don't, I want two numbers that multiply to 25 and add back to 10. And that, of course, would be 5 and 5. So you would get x plus 5. X plus 5. Or you could write x plus 5 squared.
I was gonna say another check on like number 6 is if you square root 36, you'll get 6, and if you double that, you get 12, and that middle term isn't 12.
Right.
Yeah.
Right, exactly. And also there's no way that you're going to get a negative 36 on the end because it's negative. So yeah. Okay, so number 9, we need two numbers that are, see, I think that the book is actually being pretty nice to you guys at this stage because most of this factoring is not gruesome. So I need two numbers that are going to multiply to negative 10 and at the same time add back to negative 3.
2, negative 5.
Yep. 2 times negative 5 is negative 10. 2 plus negative 5 is negative 3. So this is just going to be x plus 2, x minus 5. Okay, and number 10, first thing we do is what?
GCF.
GCF. This is one we just did, right? So
Yeah, it's the
this
same.
same thing. Only it's an X instead of a P or whatever it was. Okay, what about number 11? Now this one's a little different. Is there GCF?
No.
No. All right, so then I'm going to use the AC method. I multiply the 2 and the negative 21. That gives me negative 42. And then negative 1. So I want two numbers that multiply to negative 42 and at the same time add back to negative 1. Anybody think of it? Is that possible?
Yeah. 6 and negative 7.
Yeah, 6 and negative. I was thinking, that's what I was thinking at first, and I thought, am I thinking something wrong? Thank you. Yes, it would be 6 and negative 7. Thanks. Because negative 7 times 6 is negative 42, and negative 7 plus 6 is negative 1. So now we're going to have to split this up, and I'm going to write 2a squared. If I have a choice, it doesn't really matter which I write first, but if I have a choice, I always write the positive one first, just because that just makes, I always write the negative one first because it just makes things a little bit easier. So I'm going to write minus 7a plus 6a minus 21, because I can split that negative 1a into negative 7a plus 6a. Again, it doesn't really matter which way you do it. I just put the negative one first because it makes it a little bit easier. All right, so I'm going to group these two guys and these two guys, and here I can factor out an a, and I'm left with 2a minus 7. And here I can factor out a 3, and I'm left with 2a minus 7. Now both of these have a common factor of 2a minus 7, so I pull that out, 2a minus 7, and what I have left is the a plus 3. You can use the box method on that if you prefer. Whatever way you would rather do it is fine. Okay, and then these last two are just plain old, really simple trinomials. Here we need two numbers that multiply to 12 and at the same time add back to 7. And what would that be?
Both of them are positive?
Yeah.
5 and 2? No, that's 10.
Yeah.
No. I can't think of them. Maybe if one of them was negative, but
No.
And 4.
Yeah. 3 and 4. Right. 3 times 4 is 12. 3 plus 4 is 7. So this will be a plus 3, a plus 4. Here, this is a perfect square trinomial, right? Because is squared, and this would be 2 times 4. So if you know how to recognize perfect square trinomials, I don't know why that didn't. How would this factor?
A plus 4 squared.
Yeah. And you could use, if you didn't see that, you can definitely do it another way. And then the last type of polynomial that we have is 4 terms. Like, oh no, we still got a couple more. One more 3-term polynomial. So here I need 2 numbers that are going to multiply to -18, and at the same time to add back to -7.
-9 and 2.
Thank you, Olivia. So this will just be x minus 9, x plus 2. All right, now the last one. We're going to factor this by what method? If it's a 4-term polynomial, what do we have to factor it by using?
You can start immediately with the grouping distribution, or what is it called?
Yeah, just you're going to be grouping, right?
Grouping, I
Or
guess.
box method is another way to do it.
Yeah.
So if we group these 2 together and these 2 together, what can we factor out of these 2?
X squared.
X squared, good. And then
We'll
what
do
can we
minus.
factor out of these 2?
-25.
-5, good. You always want to factor out whatever.
But if it's 50, isn't that 25?
So it's going to be, oh yes, I'm sorry, 25, yes. Times x minus 2, right? Because -25 times x is -25x, and -25 times -2 is +50. Let's clean this up a little bit. And now they both have the x minus 2 in common. So I can factor that out. I'm left with x squared minus 25 as the second factor. Am I through?
You can factor the x squared into 25.
Right. And now I'm through. So anytime you have a binomial factor, always ask yourself, is it the difference of squares? And continue to factor if it is. Okay. So this was really the hardest part of this whole lesson, was this, and then also domain stuff, but they don't ask you too much of that in the homework. So if you'll look at the homework, the book work, and like I said, the order that we did the factoring is the order that it will appear in these problems. And I want to do, I want to do 2 of them with you, just so you'll have something to look at. But the rest of them, I'm going to put y'all in groups and let you work on them. And then we'll come back and check them. So if we look at number 33, we have already factored this. So if you look at the little sheet of all the factorizations that we've done, this would turn out to be 5p squared over p minus 9 times p plus 4 times p minus 4 times p plus 4 over 10p. Now we can, if we want, just put this all over one big make this all one big fraction. If you can, when you multiply fractions, it's just the top times the top and the bottom times the bottom. And now it's just a matter of canceling out common factors. Anything that on the top that matches something on the bottom turns into the number 1. So they cancel each other out. So like this p plus 4 and this p plus 4. And this p with this p squared. Anything else we could do? The 5 and the 10? You can cancel any factors. If 5 goes into 10, then you can cancel that. So our final answer here would be P times P minus 4 over 2 times P minus 9. And we can't cancel anything else because the P minus 4, those two things are tied together, and the P minus 9, those two things are tied together. So that's as far as you could take it. Now, they didn't ask for this, but I'm going to talk about it right now anyway. You don't have to answer these. You don't have to do this for any problem that they don't ask for. But what would the domain be on this one if we were asked for the domain? Let's look at it before it's canceled.
I think this also comes up when we do equations and start graphing.
Oh, yeah, yeah. So what are we looking at in order to determine what the domain is? What part of this fraction are we looking at? Just the what?
Denominator.
The denominator. You're just worrying about the denominator. And you're going to take each one of those factors and they can't be 0, right? So P can't be what? What are the numbers that P cannot be?
Nine.
Uh-huh. What happened here?
-4 and 0.
Yes. So, yeah. So P can't be 9, P can't be -4, and P cannot be 0. So if I asked you for the domain, you go straight to the denominator and you determine what the values of P would not be defined in the expression. Okay, and then if we're doing division, how would we write this one to where we could use division? Again, we've already done the factoring. So what do I do with this term when I divide?
Right on the bottom and put 1 on top.
So it's, well,
It's
so you're what? So like here, we're going to have to do something with this too, because that's just horrific looking. What you're always going to do is take the second fraction or the bottom fraction and take its reciprocal and multiply. Okay, so you'll take all the factorizations and put them in there and then do the cancellation. So on this one, we would have 2a squared minus a minus 21 over 5a plus 20 times what? What would be the second fraction?
A squared plus 8a plus 16 over a squared plus 7a plus 12.
Right, and then you just go from there. exactly. Then when you get down to these 63 and 67, they're asking you to multiply f of x times g of x. Do y'all have these problems on your paper? Because
63
originally,
and 67, yes.
okay, good. So you've got both the f of x and the g of x.
Well, both of these 63 and 67 are both f of x.
Okay, but they should also have a g of x with them that evidently I just forgot to put in. So if you've got your paper, write these problems
Oh,
in here.
okay. Give me a second.
So they should have two. You should have an f function and a g function. So if you're going to have f of x times g of x, you would just multiply those two functions together. And if you have f of x divided by g of x, that's going to be f of x times the reciprocal of g of x. Okay. All right, so I'm going to put y'all into groups and we'll come back in about 15 minutes and check our work.
Yeah, that's right. You tell them. Where's Miss Watson going? Where's she going? I'm trying to look and see where she's going. Y'all getting this?
Yeah.
Clicking.
Where do I want to go with this thing? Let's say that. That's weird. I hope this year is the right thing. Here it is. I watched a documentary over Who Let the Dogs Out a while back. It was kind of weird.
It was a documentary?
Yeah, it was an entire documentary about like where it originated from. This is really weird. He just like keeps going back and finding like different origins.
I just couldn't let it settle on the song, huh?
Yeah, it was just like a phenomenon. Like I think it started as a sports team chant, and like part of it got adopted from that, and then like part of it got adopted from somewhere else. It was like not just one source. I think it kind of like took several sources together, and then like it was like a recurring chant in songs and stuff for a while, and this is like it just became wildly popular with that one song.
People really know how to take it real far. I'm surprised take that amount of work just to look and to find the source of the phrase. Should just left it as is.
But I mean, like, I don't know. There's an entire world around us, and we often don't think of where like things came from. You know.
Well, I'm glad you say that because a lot of the times, most people I come across, they always want a reason why. And I always tell them or remind them that the main thing in life is to live it. And there are some questions that just don't need answers. People really don't realize that.
I don't know. I keep asking questions. I'm annoying.
No, hell no. There's nothing wrong with that. Throughout these times.
Yeah.
All right. Did she say by any chance which ones we're supposed to do? Because I only think I got written down here was 63 and 67. We just left to the breakout room. Anybody else? Anything different or we're on the same page?
And I think we're just kind of going through everything in order. The stuff for 63 and 67 was just so we had the full problem to work with.
Okay, just double checking. Number 1.
Yeah, I got these things factored already. That's like the most work.
Hmm.
It's just like you gotta play slasher now, man.
Pretty much, yeah.
Slash the right thing. What was it, A+2, A-2? Sometimes you can kind of guess the factors that they're going to give you, but sometimes it's not a good idea because that can mislead you. Sometimes it's not the thing you want it to be, right? Oh, is it 2 and 8? With the 8 being positive? Is that what I'm getting? And the 2 being negative?
I got.
All right, so we get this thing factored. Did y'all do this one already?
13?
What am I slashing? Yeah, this is 13.
Yeah.
So this thing's the same.
Yep.
Same thing with each of them, right? Just factor it out.
Same thing.
This one, I think you got like an 8B. Let's do it with this, huh? 8B. They're
Yeah,
all single. B minus 4.
Mm-hmm. And then over B plus 5 times B minus 8.
There's the 2 you factored out here too, ain't there?
Ah, yes, you are correct. I forgot
Yeah,
to write
just
it down
like-
on my paperwork.
Yeah, it's all good, Hunter.
There's my little bar. What am I slashing? What am I slashing? Doesn't look like any of these factors are
Yeah,
the same.
Just the 8 and the 2, I guess.
I can get this 8 and this 2. Makes it what? 4 up here. Makes it 1 down here.
If it's 1, can we just leave the 1 out, or does the 1 have to be on there?
No, when you finish this in the end, it's probably not even gonna be there. Like it's gonna be what? 4B, B minus
Parentheses
4.
B minus 4 over parentheses B plus 5 and B minus 8. At least that's how I wrote it. I don't know if the points be taken off.
That's
the one's
exactly
missing.
that's exactly what I'd write.
Awesome.
No, that 1 doesn't need to be there, and it typically won't.
Okay. Another day in paradise.
Now multiplying is like no different, huh?
Oh,
All we do is like look, check this out. Here's the bar. Just do this. It's literally all you do. You just like, let me see this bar. Extend it all the way, right? Everything that's on top is on top. Everything that's on bottom is on bottom. Factor those things, find common factors.
Let's write all this out.
Where'd she go? I don't know where Miss Watson went.
Probably just jumping between rooms.
I don't see her right now. Yeah.
Swear that neighbor's dog is starting to piss me off.
67, she didn't give us G of X. Where'd she get G of X?
So she wrote it down in the classroom for 67. G of X is 3x squared plus 18y over x squared plus 13x plus 42.
And find the domain. Oh, that's the one she was finding the domain on her. Yeah. She talk about 49. What to do with that?
If she did, I didn't hear it.
What do you do with 49? What's the trick there, I guess?
Oh, yeah, she mentioned it briefly. First, you make that a fraction by putting it over 1,
Yeah,
and
divide by
then
one.
switch it to multiplication by using the reciprocal of the second term.
So 1 over that 2x squared. Which I think factors into x plus 5. X plus 5.
Yes.
I think they're all positive.
Y'all got everything factored, man. I was just like, I can whiz through this thing. I'm gonna make sure everyone else is getting some time. Where are they at? All right, I'm gonna jump around. You know, I'm getting this. Are y'all there?
Yeah.
Are you getting this one?
I'm a little confused on 67.
Okay. So we're dividing this by what? What was g of x?
Yeah,
gave it-
I didn't write.
Yeah, she gave it in class. I didn't write it down.
Do any of you guys have it?
It's 3x squared. 3x squared plus 18x.
On top, and what's on bottom?
On bottom is x squared plus 13x plus 42.
And y'all should have these things factored.
That I didn't write down because I haven't had g of x written down, so I didn't know. She told us at the end.
Okay, so this is 27x squared, and then we doing dividing this by what? 3x minus 21 is going to factor into 3 and an x minus 7. So we've already done this factoring. This is copy. This one I have to flip. So that bottom, I'm just going to go ahead and factor it with what, x plus 6 and x plus 7, I think. And now I am flipping this. If I flip that top, I can factor the top with the 3x as a GCF on there. And I'm going to do x plus 6. So I divide these, I flip them. Now it's multiplication. Is that what we're doing? All right, this is the 3x, x plus 6 up here. Oh, we're about to go back. If I flipped them and I make it multiplication. And this is the x plus 6, x plus 7 on bottom. All right, so now I'm slashing things. What do I need to slash?
X plus 6.
Yep. Ooh, we're gonna have enough time. X plus 6 is gone. What else can I slash? Take an X, right? We can go sideways too, as long as it's on top and on bottom. I think I can divide this by 3. Divide what? This by 3 becomes 9. And then I can do it again with this one. I think this one becomes.
So, so all the factoring that we did in the beginning of the class, all that factoring, every single one of those problems goes directly into the homework. So every single one of those factored polynomials that we did earlier, they each go with the problems that we're doing now. So the reason I did that was to save you some time factoring. But if you forgot about that, then it would take you some time, but at least you got more practice factoring. So it's a win-win. But what I want to do now, as we're coming close to the end of the period, is to just go through the solutions with y'all. And I did these pretty fast, so there is a chance that some of them may be wrong. So make sure you're checking me as I go. And then if you have any questions, feel free to ask that too. All right, so the first one was just a fraction. So we just had to divide the 8 and the 12 by 4, and that gave me 2/3. And then m to the third divided by m is just m squared, and n over n squared would just leave you with an n on the bottom. So you just pretty much have to remember the rules for exponents and division. Then 13, we had already factored these. So we had a minus 2 times a plus 2 over 8 plus 8 times a minus 2. And the a minus 2's just cancel, and we're left with a plus 2 over a plus 8. And when people get nervous, they start doing really weird stuff like canceling a's and canceling the 2 and the 8. But don't, just, take deep breaths, and you know what you're doing on a test. Don't make mistakes like that, because you know better. So on 17, again, we had already factored these. So it just turned out to be 8b times b minus 4 divided by 2 times b minus 8 times b plus 5. And the only thing that would cancel is the 8 and the 2. Is that what y'all got? 4b times b plus 4, b minus 4 over b minus 8, b plus 5. Yes, no? Does that look right? Stop me if you see one that
think we did
doesn't
that
look
one.
right.
Did that one with one group at least, I think.
Okay, and then 33, we did together already. 36, we did the factoring. And so then you can cancel the y plus 5s. The 2y and the 6y will leave you 3. And you're just left with y minus 5 over 3 times y plus 5. Here, when you divide, you're multiplying times the reciprocal. We factored all of these already. So the x plus 5s will then cancel. And that was all that canceled. So you'd be left with x minus 2 over 8x times x plus 5. And then 51 looks horrible. So you just take the top fraction and multiply by the reciprocal of the bottom fraction. And since we'd already factored all of those, all we have to do now is start canceling common factors. And we're left with 2a minus 7 over 5a plus 5 over 5, just over 5, because the a plus 4 did cancel out. And then 59. Oh, and they asked us for the domain on this one. So on 59, first of all, when we simplify it, you just get x minus gain. Remember, we're just concerned with the denominator. That's all we care about. So we say x minus 5 times x plus 5 is my domain. And so x minus 5 cannot equal to 0, and x plus 5 cannot equal to 0. So x can't equal to 5, and x cannot equal to negative 5. So we really didn't have to do anything more than that because that's the directions. They just wanted the domain. 63, they're asking you to multiply and divide those functions. So when you multiply, it's just the f of x straight times the g of x. Factored, you just cancel everything out. And I got 2 times x minus 9 over x plus 9. And then when you divide, you take the f of x and multiply it times the g of x, the reciprocal of the g of x. So the reciprocal would just be, just flip over the g of x. And then again, just start canceling terms, and you get 18x squared times x plus 9 times x minus 9. And again, I didn't read directions. I thought they were wanting you to multiply and add all of these. I mean, multiply and divide. All they really wanted on this one was multiplication, and all they really wanted on this one was division, but I did both. But you didn't have to do both. So on 67, the division, you take the first fraction and multiply it times the reciprocal of the g of x, and then just cancel all your terms, and you wind up with 3 times x plus 7 over x minus 7. The hardest part of this lesson is just the factoring. Because once you've got something factored, then all it is matching factors in the numerator with factors in the denominator and canceling them out. Any questions or problems? And if the main thing I will tell you to be able to do is, practice your factoring, because there's going to be a whole lot of it in this section. So the quicker you get at it, the better you'll be. Matt, do you have anything to add?
Yeah, that's pretty much it. It's like the factoring. Once they get the factoring, everything else
Yeah.
is going to play slasher, basically.
Right. I will hang on here for several minutes if anybody wants to stay and chat. Otherwise, y'all are free to go.
I know one thing that like really like kind of maybe is like a new thing is like the x is different than the x plus 1. Like if we add or subtract any number, it like completely changes the beast, right? So like sometimes that just, I think sometimes people have a hard time getting that down.
They do, yeah. It's like that plus sign ties, if you have x plus 1, that plus sign ties the x and the 1 together. So you can't cancel one without canceling the other one.
But x's and x squareds over each other, stuff like that we can simplify.
Yeah.
Thank you.
Miss
Thank you. I'll
Watson-
see y'all tomorrow.
Miss Watson,
care.
I'm wondering on this very last one.
Uh-huh.
It was 27x right there.
Should be x cubed. Is that what you're asking? I think it should be x cubed.
Which one?
27x cubed up top on 67, the multiplying. I think you're missing that single x.
27x squared.
There's a
times-
square and then there's a single x that doesn't.
Then there's I left off that x.
Yeah.
I did. So there should be 3x times x plus 7, right? Over x minus 7.
Oh, I was looking at the one above that. It should be 27x cubed.
Yes,
Up.
and that one should be 27x cubed, right? Because I just completely threw out an x. You got to be careful. I've got to be careful of stuff like that. Sometimes I get so much scratching going on, I'll forget something.
All right, that was it. Thank you.
Okay, you're welcome.
Thanks.
Good catch. I appreciate it.
No problem.
Do you want me to show you my middle root factoring that I think I've perfected it now?
Sure.
I can write it out for you guys.
Okay.
Okay, so give me like a root that is kind of complicated, but not, I mean, not too much because it would take me a long time to solve it.
So what do you mean a root? A
Like,
factoring problem?
yeah, like let's say a big number, or not too big, but then like the root of 4 or the root of 5 or something. And then I'll do it.
Okay, so like the root of 35? Well,
Okay.
that doesn't have, the root of, let's see, the root of 98.
Okay, but at which power though? Like third, fourth root? Something like that?
Let's do
I'll just hold the camera.
let's see,
I'll show you.
let's do the cube root.
Oh, okay. So what number,
Let's see.
it has to be hard where you can't easily.
27 times
Think
3.
about it. Does that work? Up there.
Let me give you one. Hold on.
Let's do a root here.
How about the fourth root of 243?
Okay. Let me see if I can get my camera working here. Okay, so I guess you can see that, right? Yeah, okay. The cube root of 243?
Yeah.
Okay, so, does that look right to you guys?
Uh-huh.
Looks backwards.
Not to me. It looks fine.
Okay, well, it must be just me. Okay, so we're gonna do this, and then we don't have any calculator other than like a basic, so we're just gonna do basic arithmetic here.
Okay.
And nothing will involve memorizing any cubes or any roots at all. So what we do is I do it backwards. So 243, I want to know if it's a perfect cube first. So I'm going to start backwards and I'm going to start multiplying numbers but times themselves 3 times until I get a number that is what's called consecutive perfect roots to either side. And then this should sit in the middle of those two, where You know, you're gonna have these two numbers, and if it matches 1, then that means that this is already solved. It's a perfect cube. So we can start with the number 2, it's the smallest number. 2 cubed is 8. 3 cubed is 27. And then but it's going too slow. So we're going to increase the pace here. So we're gonna go, let's say 10 cubed. So that's what's that? 10 times 10 is 100 times 10 is 1,000. Well, that's too big. So now we'll go back down to, let's say 8 or something. So let's do 8 cubed. So you can just do 8 times 8 times 8, but I'm just gonna do 8 cubed here to save time. So 8 cubed is 512. So we'll go down to 6. 6 cubed is 216. So we're pretty close here. Let's do 7 cubed. That's right next to it. These are consecutive. We want to find here. 7 cubed is 343. So I found 2 that are consecutive. See that? Now I'm going to put those to either side. So now I found, and I've also proven that this is not a perfect cube. See?
Mhm.
And every time I write these down, like I'm going to put, let's see, 216 to 343.
Okay.
216 cube root, right? And then cube root 343. This is the longest part of the entire operation. Once I do this, it becomes much faster. Okay, so now I got that. This is what I call a middle root. I've converted this into a middle root function now. See that? So now I know it's not a perfect root. Now all I got to do is start factoring. So that's real simple. So 243, I guess what's a factor of that? 3, let's try 3 here. 43, and then we're gonna divide that by 3, and that gives us 81. So that's an easy one. 3 and 81. Now these are both cubed roots. To pay attention to. So look how much smaller it's gotten. Cube root of 81 is all I have to worry about now.
Wait,
So
what?
yeah.
Let me look. I can't see it.
Cube root 3, cube root 81.
Okay.
Right? So I've already taken this number and I've chopped it down to a much smaller number to deal with, see? So now if I don't know from my memory, and I'm pretty sure 81 is not a perfect cube. So I'm gonna start the process over again. If you're writing down all of these numbers as you're doing them, then you're gonna have all this written down and you've already done all this work. You can just go back and reference this. So I can go back, like, for example, I know that, let's see. It's like 3 cubed. For example, we'll clear this here. 3 cubed is 27. So let's go 4 cubed. See, we're doing this process again, 64, that's pretty close. Let's do 5 cubed, that's probably gonna be bigger. It is 125. So see, I've converted this to a middle root again. And I've also proven this is not a perfect cube. Again, 81, there it is. So I know I'm gonna convert this to a middle root. See, there's my middle root here. I can just write it out. And so I know that 81 sits in between the perfect cubes of 64 and 125. See that? And you notice how much faster it's getting each time I'm doing this because I'm working with smaller numbers. There's my second middle root I've converted right there. Okay, so I know that this is not a perfect root. It doesn't match either one of these consecutive perfect roots. I'm going to factor it again. 81 divides into, I think, 3, I think. 80, let's see here. 81 divided by 3. Yeah, it's 27. You see how I've created another perfect root that's already done. This is another 3. Oh, let me see if I can get it. Let me see if I can get it. Where are you? There it is. See, there's my second one. See that? I circle it. I'm going to save these for later. So now what I've got left is 27. The cube root of 27. Now all I got to do is figure this one out. And I already know from memory that it's 9, but I'm gonna pretend like I don't, or no, 3, excuse me, 3. But I'm gonna pretend like I don't. So we'll start our, we do the backwards. So since this is perfect cube, we cube our numbers to guess them, right? So I'm gonna convert this down to a middle root again. All right, so here's a middle root. There we go, see? We're gonna convert it into a middle root again. So we're at 27. We get the, here it is. And so we're gonna convert this to a middle root. And so, let's see here, 2 squared is 8. Or cubed, excuse me, cubed. 3 cubed is 27. I've converted it into a middle root again, but this time, unlike last time, it is a perfect, it matches one of the 2 consecutive perfect roots. I'm trying to get this camera here to look at the darn thing. There it is. So now what I'm gonna do is I can, if you can see that, see how there's 2 matches. So you just, that is been successfully converted into 3. And that's it, that's your answer. Now you take 3, you take these other ones that we circled and we put them all together. So that's going to be 2 cube roots of 3 and 3. And then you just simplify it from there. See that?
Mhm.
Yep. And so each step of the way, you don't have to memorize a single perfect root,
Well,
and you
wait,
can work with
Michael,
extremely perfect
I'm,
complex ones. Yeah.
so what's your final answer?
Oh, well, you simplify this out. So these are all multiplied by each other, and you just make it look as good as you can. So,
What would you write down though?
well, I'd put 3, let's see. Yeah, these 2 should cancel out because they're, oh, no, they're actually no, because there's 2 of these. So I guess if you multiply cube root of 3 by cube root of 3, I guess you get cube root of 9, I suppose. I don't know what that
That's
would be.
right.
Yeah, so cube root of 9. Yeah, so that should be the answer. 3
Okay.
cube root of 9. That's it.
Well, that's right. Yeah, that's,
Yeah, and so this prevents you from having to memorize a single root function. Yeah, so I came up with that, and I think it works pretty well. I've tested it a few times.
cool.
Like I said, it seems like it's long, but once you get started with the first part of it, it becomes a lot faster and a lot easier to do it. But yeah, so I put a lot of work into that, but
Yeah, well,
to show
thanks
you.
for showing us.
Okay, I got to get ready for work, guys.
All right, sweetheart.
Thank you very
See
much.
tomorrow.
See ya.
Bye-bye.
Bye-bye.